how was lunch? All good? Yeah? Happy? Okay. So, yeah, let's start with some questions apart from how was lunch. So, who here uses a Spring framework usually at work? I mean, it's a Spring I/O. I would be surprised otherwise, right? And Spring Boot? Okay, good, 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 good. And who has its own framework, company library, some kind of extension on top of it? Yeah, last time I asked, no hand was raised. So, okay, good, good. Are you happy? I mean, not in general. I mean, with the framework. Yeah, let's re-ask. Yeah, okay, the kind of answer I like. Good, good. So, okay, my name is Rubén. This is my first talk in a conference, so please be nice with me. And yeah, apart from that, I'm tech lead at Travix International. And one of my main duties last years have been mainly designing, redesigning, and rewriting the framework Java, the framework we have on top of Java, based on top of Spring Boot. And I'm currently maintaining it. So I'm going to talk about that. And first for this, I'm going to ask the question, why do we need a framework? This is the first question we have to ask. And reason is, OK, we need production readiness. All our applications have to go to production in a ready way. What do we mean by production readiness? Actually, there are a lot of things that we have to take into consideration when we ship to production. One could be just standardizing somehow the communication. We are mainly talking about serialization, things as simple as when we send a date, how do we serialize it? Which standard are we going to use? Also, error handling. I mean, when we have more than one application, it would be nice if somehow they are talking some kind of common language. Of course, the API for the model will be different, but when we talk about error handling, we can kind of standardize it, saying, OK, this is going to be an error code, this is going to be the tail message, any information is going to be there. We also have to record how the application is behaving, right? We talk about metrics, so we need to know when we ship something to production, how it's behaving, the latency, error rate, kind of a lot of stuff. We also have to log, so it's just not as simple, OK, error rate has going up. Now I have to understand how it's gone up. So logging comes into troubleshooting. I'm going to troubleshoot specific incidents, and I need information about what's going on in the system to reproduce it, understand it, and ultimately fix it. And logging comes with its own complications, right? There's this thing called GDPR, and on top of that, we might be just logging payloads, and on those payloads, we can have credit cards, for example, something that we don't want in plain text in the logs because they shouldn't be there. Not only that, we also need traceability. So when we're talking about microservice infrastructure, for example, so we have multiple microservices, we need to understand what's going on in the system. And for that, the common thing is just tracing. Tracing means as of a user doing a request to our service, and then our service will communicate with other services, and so on, and so on, and so on. We need to understand the whole picture, and this is what tracing comes into place. On top of that, we can be part of tracing, actually, but in our specific business, it's very important to understand the user session. It's not just going to be a request. It's going to be a set of requests that the user is going to log in, do some stuff. And ultimately, we need to understand what was going on, and how can we improve the user experience in general. We also have to care about security. This is a very hot topic at the moment. So dependencies in general. Who heard here about the Log4Shell, for example? Yeah, nice, nice. OK, so we need to make sure that we are not shipping applications to production with dependencies that are vulnerable. When a CD is detected and then it's fixed, we need to make sure that our applications are applying that fix. And also, we have to be very careful with what we expose. Something as simple as if we are using Actuator for metrics and other stuff, we have to make sure that we are not exposing things like M. We might have some API keys there that we should not be exposing. We can have the shutdown endpoint, and etc. So we have to control this. And all of this, and this is the key part, has to be done at scale. At Java in particular, we are, at Travix in particular, we are 2 Java teams, 5 people each. And we maintain 150 microservices plus. So actually, it's closer to 200, again, 10 people. And these are just microservices. Then they have their own instances, and we're talking about thousands of instances in production. And we want all the things I mentioned before on all these applications. And we still need to have time to develop our features, right? So let's very quickly talk about the previous approach, or what went wrong. And yeah, I'm going to be very quickly. That doesn't really matter much, just to get the idea. So we were doing something like we would have our own classes on the framework, and we would say, OK, kindly, when you create your application controller, just make sure it extends our framework controller. And then instead of just directly going to the service layer, please do it through this decorator method on the superclass. So you are going to use our class to decorate, and we can add all the stuff there. When coming to from our service, communicating to another service, it would be exactly the same idea. Instead of just using web client, REST template, just inject our framework REST client. It's similar, just you have to use it for this. OK, so now when I want to do a post, I just call its method, send the API it's expecting, and it will just do the magic for me again. And of course, we are adding this REST client to the context. We might be adding other stuff. So we need it in the context. In order for that, just kindly, please, on your application, import our configuration. And that's it. It just works, right? And this is more or less the developers at this stage. They say, OK, cool. I don't have to care about all the things that you mentioned before and all the things you didn't mention that also are important. So we are happy. But what were the observed issues with this approach? The first one is just obvious. The applications are coupled to the framework. Now we are just developing against interfaces that we have to extend, against specific methods that we have to call on APIs that are there, which means that when we develop these APIs, one clear example is the framework client that I showed before, we have to guess what developers are going to need. OK, they're going to need to do post calls. And now what happens if I need a patch? What happens if I need a get with a body? I will have to just either do a lot of things without knowing if applications are going to need them, or just do as we go. And when we do as we go, we are creating bottlenecks for applications. Now applications have to wait for the framework to support something in order to be going to production to do what they are supposed to be doing. And then, in general, and this is for me the most important thing, this is useless knowledge for developers. So now people join Travix. They will just be doing what they have to do. They learn how to use our tool. After 2 years, 5 years, whatever, they leave. And next company, these tools are not there. They just don't know how to do things, or at least they didn't learn from our tools. So it's useless knowledge. We should try to avoid this. OK, people less happy, still happy. But yeah, so this is a trade-off, right? We can argue it's a trade-off, and OK, we don't have to care about other things, so I can live with that. But then who here heard of Stack Overflow or uses Stack Overflow? OK, who here copy-pastes from Stack Overflow usually and doesn't care to admit it? OK. Not anymore, OK? That's not possible, because now we are not talking about Spring APIs. We are talking about our code. OK, maybe we're posting our issues in Stack Overflow, but I doubt it. So you just depend on people that know about the framework and just can help you on that. But it's just something that doesn't scale well. So yeah, definitely that's a no-go. And people are just crying inside of it. So let's talk about our current approach after we understand these issues. Let's see how we can just do something better, mitigate them. And I like very much this definition of what a framework is and how it differs from a library. And mainly it talks about inversion of control, right? What it means is that when I'm using a library, I'm expecting to have a contract, an API that I'm going to code against. I'm going to use it. Whereas when I'm using a framework, it's the opposite. I'm just going to provide some stuff, and the framework is going to call me. That's why it's called inversion of control. And this is, for me, is the key difference. What I saw before is actually a library. It's not a framework by this definition. So that's why I like this definition. So yeah, when we talk about designing this framework, there are 3 main objectives we have in mind and are very important. I want something that just works out of the box. I don't want to have to add new lines of code, extend classes. I just want to write my normal code, and I want the framework to be working for me in that case. I want it to work in a transparent way. It's just, I don't want to know about the framework at all. It's just there. OK, that's its job. Transparent. But of course, with transparent things, out-of-the-box things, now there might be situations where the default behavior is just not sufficient for us. We need all the stuff. Let's say I'm logging something, but OK, sometimes I want to log the payload, sometimes I don't want. OK, let's make it customizable. So it should be like that. Works out of the box. I don't notice it, but when I need to differ from the opinion that it has, I can still customize it. So if we focus on the things I mentioned before about production readiness, we have this list. And actually, the list is way longer, but this is enough because these things, it doesn't mean that we have to do all of them. And that's why I like the list. It's just simple enough to go through it. We don't have to reinvent the wheel, right? And these things, actually, they fall into 3 different categories. On one hand, we have things that just are provided there out of the box. It means that there's already a third-party library, Spring, or whatever, that just does the thing for us. So we don't have to care about doing it. We just have to use it. On the other hand, we might have some things that need some tweaking. So still are provided for us out of the box, but maybe the defaults that they come with are not good for us, because our company has other opinions. And then on top of that, there might be just missing features. By missing features, I don't mean things that, OK, nobody thought about logging on your application. It's just maybe our company might have some way of logging that just it's too difficult to get by just adapting third-party things, and it's easier to just do them from scratch if they are not too complex. Again, how we put them in the categories is just up to us. Some people might differ. It doesn't really matter. What matters is there are 3 categories, right? So let's see how we can go through these categories. Let me get some water. And mainly, let's see how can we achieve all these things, because this is a long list of things that we have to do, right? So let's start with the things that just work out of the box. So I'm mainly talking about adding tracing to our applications and controlling the dependencies and which versions we are using. So for tracing, it's as simple as on our POM file on the application itself, we can just add a dependency. For tracing in particular, we have OpenTracing, we have OpenTelemetry, we have Spring Sleuth. It just depends on what you want to use. In our case, initially we went for OpenTracing Spring Jagger, and we might just change it. But the thing is, we add a dependency, and this dependency will just be added to the application, and it will just work out of the box. When we're talking about a library, not the application code, the only difference is this dependency can be added transitively. So when I depend on the framework, if the framework depends on this, it will just bring it for us. So essentially, we are done. In order to control dependencies, again, this is something that comes out of the box, in this case from Maven. Gradle has its own mechanism. And mainly, it's called dependency management. So dependency management, I can say, this dependency in this version. Actually, I can configure more things, not only the version, but version is what's important for this. So this reads as, I want this dependency in this version, meaning that it will not come transitively, but out of the box, the application will not have Jagger, but if it depends on Jagger, and it doesn't specify the version, this is the version I want. So now I can say, OK, Jagger, use it in this version. The other thing, use it in this other version. And that's it. If you want it, you have it in this version, unless you have an opinion and override it. So again, it's customizable. But otherwise, that's it. And then on this dependency management, we can see this is mainly one of the best features that Spring Boot has. It's very simple, but it's OK. It gives us this long list of dependencies on the versions that we need them, and they just make sure that everything works together. And also, they make sure that things are patched. So what we can do in our dependency management is say, OK, this is my dependency management, but also I want to extend the Spring Boot one. So I'm still just not going to reinvent the wheel. I'm not going to maintain the same. I'm just going to use the Spring Boot, but then I also have my own dependencies, might be additions on top of that. And this is very interesting. When we play with these 2 things together, we can now achieve something that is amazing. That is, when we have different opinions, so a conflict on this is saying I want version 1, this is saying I want version 2, Maven is going to resolve, and it's going to resolve in a particular order. What it does, it's closest to root will be resolved. So what we can do is we can still use Spring Boot dependencies, but then on top of that, we can have things with higher priority, where we can say, OK, I want to have a different opinion. And why this is important? Log4Shell, I mentioned before. When it was discovered, Spring Boot was going to fix it, I believe, the week after, because it was the next release. So in that time, all our applications were vulnerable. As simple as we can have our own dependency management with higher precedence, and while Spring Boot doesn't solve it, we can just have a different opinion and say, OK, just use log4j in this particular version. And then that's it. I just have a different opinion from Spring, takes precedence, and patching all our applications. 150 applications just patched from a single line of code in the framework. When Spring Boot aligns and finally releases the new version, OK, now we want to align. We just remove it, because now Spring Boot is not bringing the vulnerability anymore. This works with Spring Boot. It might work with any other application or any other dependency. So I think this is very good, and it has tested mainly with this log4shell. As I said, we fixed it in, I believe, 4 hours. So just because it's what took to rebuild everything and redeploy everything. So OK, and on top of that, nice touch. I mentioned before, if I add a dependency on A, and then I depend on the framework, A will come transitively. But also, we can play with the concept of starters. This is something that Spring Boot uses also. So a starter is like this, right? I have a normal project just with a POM. It will not have code. It will just be a POM XML. And I have a name, Spring Boot Starter Web, for example. And then the Spring Boot Starter Web will have all these dependencies. So it depends on Spring Boot Starter, JSON, Tomcat, whatever. So this reads as, OK, I want a Spring Boot application, a web application for Spring Boot. And Spring Boot has this opinion of, usually you need Jackson, you need Tomcat, whatever. If you don't agree with that, clear example is I want to use Netty instead, or Yeti instead of Tomcat. OK, so I will just add the exclusion on the dependency. So when I add my Spring Web, I will say I want to exclude Tomcat and just add Netty, Yeti, Undertow, whatever. And that's it. So it's just an opinion of, usually you need this. Similarly, from the framework, we can do exactly the same, right? We can provide our framework starter web. This means at Travix, a web application usually needs this. And this means, on one hand, I can add Spring Boot starter web. So it's still a Spring Boot application web. Remember, it's on top of Spring. We are not replacing Spring. But then we can add our own stuff. We can add our auto-configuration. We will see in a bit what this is. I can add metrics, logging, any module. And that's it. Now our application will just have a simple dependency, and we are taking care of everything based on focusing on dependencies in this case. So now let's jump into the things that are still there, but they might need some tweaking. And the question is, how can we configure dependencies in Spring? Meaning, I add a third-party dependency. How can I configure its default behavior? And mainly it comes to two options. On one hand, it might be just via configuration properties, so we can have these properties that we write and control the behavior. And also, sometimes they just expect some beans to be added to the context. So we can implement an interface, or we can just provide another kind of class. And the framework, or this third-party library, or whatever in particular, is going to just use it. So this is the two main ways we have to configure the dependencies. Let's see one by one. Configuration properties. How can we add configuration properties to our application? Very simple, right? Application properties file, or we can have a specific for an environment, whatever. And we just add things. So we can say here, OK, I want to enable metrics. I want to only expose Health and Prometheus, so I'm not exposing EMP. I'm not exposing shutdown, this kind of stuff. I want to enable Prometheus, whatever. It will depend on what we need. But now we have our issue here. Application properties go on the application. We are not writing code in the application. We're writing a common library that has to provide this for us. Solution, super, super simple. Let's say application properties. OK, let's not call it application properties. Let's call it something else. Name doesn't matter. We're going to call it framework metrics properties, because we are mainly focusing about metrics here, right? Kind of. We still have the health and whatnot. So, OK. And then the key part is we can provide a configuration class from our library. And we can add this nice line here, property source. What we're saying here is, I want this configuration, when it loads, to also read this properties file and apply the properties. So now what we're doing is, OK, that class, those properties from before are going to be evaluated from the framework side. So we don't have to add them. And the precedence is lower again. So if my application has a different opinion, it can just replace any of those properties that are set there from the application properties. I will just take precedence. So it's going to override. It's customizable. It works out of the box if you don't have a different opinion. So far, so good. Now let's see how we can register beans. Some things start to get a bit more complicated. In order to register beans, we have many options, but the two main options are just adding a method annotated with add_bean. We're going to see it in a second. Or we can scan for the annotation add component. For adding the add_bean method, it would look something like this. We can have a normal configuration class. And in the configuration class, we can do things like, remember, we are talking about how to customize third-party things. So in the case of micrometer, for example, it will always work the same. So add_bean is a method that you return an instance. That instance becomes a bean added to the context. So it's now going to be there. For micrometer, we can register new meter binders. So in this case, a meter binder is just some new instance that is recording a metric with a name, and is going to add it to the existing ones. So here we are saying, I care about the JVM memory metrics. So how memory is being used by the process. It could be anything else. But also, we can use it to customize existing ones. So meter filter for micrometer, again, in this case, is just a filter that when this meter binder is created first time, this metric is registered, it will go through these filters, and these filters can change them. So for example, here, what we're doing is, I care about the metrics. I care about specifically the latencies of the server or the client. And I want to log them in a particular way. So we are going to run an histogram, so we can then calculate percentiles, and we want all these histograms from hundreds or thousands of different instances to use the same values for the buckets that they are creating. So when we aggregate on Prometheus, we don't kill the Prometheus servers. So we can see, we can just add new stuff, customize default ones. Apart from metrics, we can also talk about serialization we mentioned before. There might be 1,000 different ways of doing this. One way would be as simple as just, I can provide an instance of object mapper. Object mapper is the class that Jackson is going to use to convert from and to JSON. So we can say here, this is the specific way I want to handle the dates. This is what how I want to handle. So different things like unknown values on enums. I want null, do I want to fail, etc. We can all configure it from here. And then we had another way, right? Add_bean was one option. Scanning for add component is a different option. And in this case, it's super simple. Again, we have a configuration class. We annotate it with add_component_scan. So add_component_scan will just look from this, by default, from this package, all the sub-packages for classes annotated with add_component or any stereotype. So it's not only add_component, but we have add_controller, add_service, add_repository, add_configuration itself, controller advice, etc. So for example, we can use this to provide our own controller advice. That will be the class that is intercepting the outgoing exceptions and converting them into our standardized response in this case. So again, we're getting there, right? But another issue, and we're starting to run into more and more issues, right? We saw that both add_component_scan and add_bean just rely on a configuration already being added to the application context. But we have no control over that application, so we just cannot register it. So how can we register configurations? There are two ways. There are many ways again, but two main ways. One would be component scan. I just said component scan looks for a component, and add configuration is one of the stereotypes of component. The other option is just from a configuration, we can do add import. And we can say, I want to import this other configuration, and then it will be loaded. But again, in order to register a configuration, we need a configuration. So we see here the loop, right? We don't like this. So how can we solve this? So we can just go to applications, so the developers, and say, OK, yes, please, kindly, on your application, add this import metrics configuration, right? And then that's it. OK, it's a trade-off. I'm just asking you, add a line of code in your application, and then I do all this magic. I think we can agree on this is a good deal, right? Reality is that it's not that good, because as the things evolve, we might be looking at something more similar to this, and actually probably a few more lines. The reason for it is because we are assuming that we can just have a common configuration, but reality is that we are going to have reactive applications. We are going to have servlet-based applications. We are going to have maybe applications that use PubSub or something else. And they might be optional things. So we cannot just import all configurations. So we are going to need these granular configurations. And this doesn't scale well, right? And actually, this is not out of the box. That was the first thing we were asking for. So I don't believe this is good enough. I believe we can do something a bit better. And to the rescue, they just come the auto-configurations. So what is an auto-configuration? An auto-configuration looks something like this. You might say it's just a normal configuration, Rubén, but it's just called auto-configuration. It's not that magic, right? Actually, it's not. We can just create these classes, and we can register them on this file. So on the library, we can add this meta-inf Spring Factories file. And we can say enable auto-configuration. This would be the qualified name of the annotation, actually, the one that we might use sometimes to opt out on some auto-configurations from third-party libraries or Spring itself. And then we can just point to all the list of auto-configurations, of configurations that we want to be registered automatically. And this is exactly what happens. When I depend on a library, and that library has these Spring Factories saying, I want these auto-configurations, at the moment, when the application starts up, it will just automatically evaluate these auto-configurations, so we don't have to register them explicitly. So now we are solving the issue. Just as a side note, didn't have time to adapt the slides, but from Spring Boot 2.7, we can just, instead of do this two-step, we can just replace add configuration for add auto-configuration, and we don't need this file. So automatically, just doing add auto-configuration, the configuration will become automatically viable. OK, so now auto-configurations are not just configurations that are applied automatically. I mean, that's one of the use cases, but they are way more than that. And they have their own features that are very useful. So we can do auto-configurations. As I said, when they are on the file, they are going to be always evaluated. But they can be optional, so they can be conditional. They don't have to always take place. So for example, we can make them conditional on the application type. As mentioned before, we can have reactive applications, servlet applications. OK, we can do conditional on web application, type reactive. If the application is not reactive, this auto-configuration will not kick in. So nothing will happen. And we can add some debug logs to know exactly how they are evaluating or so they are kicking in or not. Not only that, we can also do many other things. Actually, there's a conditional annotation, and we can see all the implementations, and we can even write our own conditions. But mainly, we can do things like, OK, conditional on a class. If this class is in the class path, because I'm talking about an optional library, in this case, object mapper probably will be always there, but let's say I'm using Hystrix on some applications. So we can create one auto-configuration for Hystrix, only evaluate if Hystrix, whatever class from Hystrix is in the class path. Otherwise, just ignore me. We can also provide conditional beans. So we can do conditional on missing bean. Conditional on missing bean means when you evaluate me, just check the context. By default, it's going to expect a bean of object mapper. If there's already one, so the application or somebody else is providing one, then just don't do anything. Don't provide this bean. Otherwise, this is my default. So again, we're providing now default implementations of classes, only if the application doesn't have another opinion. And we can play with orders, something we cannot do with normal configurations. We can say auto-configure me before or after this other configuration. We can also give some orders in like add order mainly. And this is very interesting, right? When we play with these two things together, now look at how this works. So I'm asking, I want you to evaluate me before the Jackson auto-configuration. And I want you to provide this object mapper only if there's no already one provided. How this is going to take effect is the application can provide its own object mapper. And then I'm going to see there's one, I'm going to ignore it. And Jackson is doing exactly the same. So they will also respect application opinion. But when the application doesn't provide it, I'm saying, ask me first, not Jackson, me first. I'm going to see, OK, application didn't provide something, I'm going to provide it. And then when it's Jackson's turn, it will always see one, either the application one or mine. So now I'm overriding the defaults from Jackson. Yes. Again, there are my other different ways of doing the same, but this is, I think, is a very clear example of how this is very powerful when we combine all these mechanisms available in auto configurations. OK, so now the best part. So missing features. As I said, might not be things that are not there. We all know there are ways of logging in Java, definitely a lot. But these are the features that we just might need to do from scratch because it's easier. So let's see, missing features. There might be into two categories. On one hand, we might have the ingress things. So this just the incoming traffic to our application. So we might need to add some logic when we receive a request. Logging is one example. We want to log what's coming in the application, but also what's going out. So we are going to focus on egress also. That is the outgoing traffic. So ingress would be a request comes from a client or other service to our application. And then egress will be our application just calling another application or endpoint or whatever. So OK, how can we customize ingress? Customizing ingress is very simple. We can just provide a component that implements the interface filter. This is going to be a filter in a servlet application, and we'll have access to the request, the response placeholder before executing the code, and then the filter chain to just carry on calling different, different filters, and ultimately just calling the controllers. And what we can do is something as simple as I can log the request before sending it to the controller, so the rest of the filters and the controller. I can just carry on with the filtering, and ultimately I can just log the response after it's populated. Again, if we try to log the response before calling the do filter, the response will not be populated. We cannot travel back in time. We're trying it, but not yet. And then, of course, it's not just about observing stuff and just reading it. We can also interact. We can store information. So, for example, when we're in a filter and we're talking about a servlet application, in servlet, we have a thread assigned to the request, and it's going to be common for the entire lifecycle of the request. So we can store things in the thread using thread local. We can use directly MDC. And mainly, we can put something like, OK, I want to check if the application is debugged. And if it's debugged, just set the flag on the MDC. It's going to be available down the line for the rest of the filters, for the controller, and for anything else that we might add later. And then just carry on. So just add some information to the thread if it's there, and continue. For web filter, so for web flags applications, so reactive applications, it's going to be almost the same. We have a different interface. Web filter, server web exchange will be both request and response will be available there, and we still have the chain. The only difference is that in reactive applications, we actually don't have a thread per request. What we have is this kind of event loop, where we have I/O workers that are going to just randomly take care of the, not randomly, but we cannot anticipate it, are going to take care of the I/O callbacks. So we cannot guarantee which thread is going to be there, so it would make no sense to store things on the thread, as we would be just overriding all the time, and there's no guarantee we can read it back. So instead, we can write to the context. The context will be something that's stored at the subscription level, so for the entire subscription, again, it's going to be common. Different API, exact same concept. I can just register some stuff there, and will be available for everybody, in this case, upstream. And now, egress. So we see how we can intercept and do whatever with the incoming request. Now, with the outgoing request, it's going to be almost the same. We have a different interface. In this case, it's client HTTP request interceptor, but it's the same. Just takes care of the request, takes care of the body, and takes care of the execution. This is for intercepting calls with a REST template. And we can do the same as before. We just log the request, carry on with the execution. So more interceptors, ultimately, it executes the I/O call. And after that, the response is available, and we can just log it also. And we can read the data that our filters are putting in. Again, very interesting, right? Now we can just go to the MDC and say, OK, just get me this flag. Is it there? OK, if it's there, then I'm going to add this extra header. So I propagate the debug flag. Potentially, the logging filter can say, OK, it's debug. I want to log more information, like maybe the bodies, whatever. It depends on the requirements. And then that's it. In the case of filters, we were talking about components, so classes that already live in the application context and just take care. In this case, it's different, right? These are interceptors that we have to manually add to our REST templates. So mainly, as we build the REST template, and I say I want to call this service, just build it, I want to add these interceptors. I have to add them manually, mainly like that. So I would say, OK, this REST template that I'm building, I want it to have the debug, I want it to have the logging, whatever. And for the reactive part, it would be exactly the same, right? In this case, we just implement another interface, but again, similar to the previous one. And what we do is we also have access to this context that we stored before. In this case, we read it with mono, deferred contextual, or maybe they already changed the API because Reactor is just changing very quickly. And then, yeah, we can continue again. So we could do exactly the same as with Servlet. And in order to add it, again, exact same thing. We just build our web client, and we have to add the filters manually. OK, not bad. But this is not out of the box. And yeah, so we have to do this a bit better. So how can we do this a bit better? Mainly, it just comes to modifying the clients. That's what the application is having to do at this stage. And let's see if we can automate it, right? So the REST template client, in this case, there's an interface called REST template customizer that will just be called with all the REST templates that either are created on the context or just created by a REST template builder. And it just has full access to it. So what we can do is just create our own REST template customizer, add it to the context, and then just says, OK, just get the interceptors and add new interceptors. So now the two lines that we were doing before don't have to be done. And from the application, it looks as simple as this. There's one requirement, is that when you build your REST template, you have to inject the REST template builder. This is actually not our requirement only. If you see Spring Boot documentation, they recommend this, mainly because if you're using things like Actuator and you need to intercept metrics for your clients, this is the only way that the magic can be done unless you want to do things manually. So this is always good, best practice, regardless of you using the framework or not. And then your code just looks normal code. This is what I'm expecting. I just want to do a call to this guy. So it's out of the box. It's transparent. I just have no idea what's going on here, right? It just happens for me automatically. And for web client, it's actually slightly better. You have also web client customizer. You can add it to the context also. In this case, you don't have access to the REST template that is being created by the builder. You actually directly have access to the builder. So what you can do is just provide your own implementation and saying, OK, just add the filters. Again, we're just copy-pasting actually cutting and pasting the lines that we would do on the clients manually from the application. And instead, we are just doing it directly from our components in the framework. So now it looks exactly the same. Same requirement. Just please inject the builder that is already provided for you from Spring Boot. We are modifying it, and then just do your call. Cloning is just very important in this case because builder doesn't create a new instance every time as REST template. Again, not because of our framework, just best practice. So I thought it was a good idea to put it there, just a reminder. So OK, now we've seen, and this is mainly the core things we do at Travix. We are just calling external services, or other services in our infrastructure. And now, how can we customize other classes? So there are many options, right? We saw that REST template at one client have their own customizers. It might be that another class that you're using also has its own customizers. It might be that not. So if it has, just use the customizer if possible. Otherwise, there's another way in Spring to just modify absolutely any Bean. And this is the BeanPostprocessor. So BeanPostprocessor is a specific it's a special type of Bean that just intercepts. So it's created before anything else, and intercepts the creation of the beans themselves. And it has two methods. You have the post-process before initialization. This would be the bean is created, but still not fully initialized, so post-construct and this kind of stuff are still not executed. Or you can do it after initialization. So the bean is just fully ready and just go into the context. And yeah, look at the interface also. It's very interesting, right? It just receives the bean, the name, which sometimes might be useful depending on what we're after. And then we can just return anything, any object. And this can be used for many things. We can use this for example, just intercepting the creation of any of these clients that don't have a customizer and manually calling some setters that might be there, or maybe we can just do some reflection if needed. And then last resort, and this is an example, doesn't have to be done like this, but let's think about PubSub template. It might not be customizable at all. And we still need to intercept the incoming request, what might be coming back if we are just subscribing through it. We might need to add some extra headers, whatever. So we can just say, OK, let's check if the bean that is created is a PubSub template. If not, I don't want to touch it. But if it is, last resort, we can always create our own wrapper. As long as the class is not final, it's extensible, we can just create our own class, similar as we would do with an aspect, maybe. It's just in order to show that we don't need to rely always on aspects or just other kind of heavy proxies. If it's something with a simple interface, we can just extend it. It could be as simple as that. Then we just override and delegate on the methods we want to intercept. And it would be done. Again, just the options are illimited in this case. And yeah, so we talked about, oh, you cannot see properly the slide, pity. So yeah, how can we customize this? So far we've seen why we need a framework, how not to do a framework, how we want to approach it, and how we can achieve it. But now we still need, we're still on the out-of-the-box part. Now we need something that we can still say, OK, not good enough. Let's try to customize it. So how can we customize? There's like two kinds of behavior here that the way I see it. On one hand, we have high-level behavior. High-level as of filters, for example, are things that we are not even interacting with them. So a filter is just in place, doing whatever. I don't notice it. I don't know it's been there. And then we also have some explicit things that we are coding in Java, like, for example, web client, REST template, are classes that we are explicitly using. So we are kind of aware of them. So let's see. For the high-level configuration, we just saw before, we have properties. So we can just use the properties. And we can say, OK, I just want to log the request body, log the response body, just customize my buckets for this application in a particular way, whatever. And then on the logging filter, we can just use this log request body and log response body, for example, saying add value. This is the name of the property. Just place it here. And then my code will use it. But are there better mechanisms that add value? I think so. And we can use something different, something that is called configuration properties. So configuration properties are just classes that we use, are going to become beans in the end, added to the context, so we can inject them. And mainly, they just represent our model for a particular set of properties. What we do is we take a normal class, annotated with configuration properties, and we give a prefix, in this case, framework server log, and then we provide a set of fields. And these fields are going to be the properties. So in this case, we're going to have log request body, log response body as the specific properties under that prefix. And also, we can just use this annotation, constructor binding, to make them just only getters, so immutable-ish at least. Because immutable is hard to achieve, but in this case, yeah, it would just have getters, and the constructor will inject all the values. And then, yeah, we just have the properties, so we can see log request body, log response body, and they are just going to match our fields. If we are paying attention, we see that log request body was written with dashes, whereas our class is still camel case, as is the standard Java. And one of the benefits of these configuration properties is that they just have this kind of non-rigid binding, where we can just have different ways of putting the same name, and it just understands that one is equal to the other one. On top of that, it's also very useful because it understands some types. So for example, we see here we have other properties, timeout and strategy, that have a duration and an enum. And when we set them, look at the duration, for example. Now it's 5s. One of the things I hate the most is when we have timeouts in milliseconds in these properties, where now you have to understand that this massive number is 1 day. Here you would put 1D, and it's just self-explainable, right? We don't have to worry much about it. And for the enums, it would be the same. You just put the value of the enum, it will just translate. On top of that, this is just the best touch. There's this dependency called Spring Boot Configuration Processor. This is something we can add to our modules where we have configuration properties. And what it will do is it will understand the properties we have there, and it will generate metadata for our IDE, which means that now we have this file with its own Java doc, and it will understand the Java doc also, and will give us, OK, for this specific prefix, we can autocomplete on the IDE, and we will even be able to see the definition of those fields. So what is this field going to be used for? So we have live documentation, which is always the best documentation. Usually the only documentation. Okay, now we can talk about the explicit configuration. We already saw this, right? In order to configure the clients, if we want to configure the REST template, for example, we have the REST template customizer. What can we do here? There's no other way. Now, the applications will have to know exactly what they want to do. So what we can do is create this kind of static factory. So we create this REST template customizer class, and we just return instances of REST template customizer, and with very clear names. So log request body. It means I want, in this particular call, to log the request body because it's not logged by default. Same for response. I can also want to compress the request. And what we can do from these things that we can even write them directly as lambdas here or whatever is just, OK, I get the interceptor, for example, and I just set a flag. So by default, the interceptor, when it's created with the flag to false. And now when I want to log, I set it to true. Done. On other scenarios, we might just want to interact with the chain of interceptors and add a new one, because now we want to compress the request, for example. Again, all possible. And then it's very cool because we have this live documentation. So this would be a normal call. And now let's see that I want to customize the default behavior. I want to add some stuff like logging the request. As I build the call, I just do these additional customizers. And you see, I just know the class is REST template customizers. One thing I have to memorize from all this talk at the moment when I'm using the framework, and just autocomplete. Oh, I can log the request. Oh, I can compress it. I can log the response. I can do X, Y, Z. Just all there. Just 2 lines. Of course, in this case, we have to do it explicitly. We are just changing the default behaviors. For web client, this is slightly better. Web client, when we build not when we build the web client, but when we build the call we are doing with web client, we end up with this request headers spec. And here, there's the concept of attributes. Attributes are just some information that is going to be added on that call as part of the code, a variable for the interceptors that we have, but that are not going to go through the network. So it's not a header that I'm sending. It's just some way of communicating from my code to the interceptors that the web client has. So what we can do is, similarly to the REST template attribute, now the customizer I showed before, now we have the web client attributes. And the web client attributes, we can just implement, again, statically, these methods, or log request body. But in this case, I don't have to interact now with interceptors. All I have to do is say, OK, put this attribute. Log request body true. That's all I have to do. And then from the interceptor itself, the exchange filter function that is intercepting the call and doing the behavior, I can say, OK, let's see. Is the attribute present? Yes, no. If present, I know I have to log the response body or the request body. Otherwise, I know I don't have to. And that's it. It's super clean. And from the code, it would be the same. In this case, I don't have to go to the builder itself. But as I'm building the request, and I'm saying I want to do a post, I want to send this body, just give it as a test response class instance. Now I say, OK, just add these attributes. I want to log the request body. I want to log the response body. And that's it. I'm just communicating to the interceptors. This is what I want you to do for me. I don't care about how it's implemented. And again, I have a list of all the things I can do there. So default behavior is out of the box. Extending it is auto-completed, either from the configuration properties, either from the attributes or the REST template customizers that we have. We just need to remember 2 classes. OK, just extra and last thing here. So we are talking about how to do these high-level things, how to customize also the explicit things. But now also, there might be some default behavior that we want to change. And this is just comes to just following kind of best practices when we design this. So for example, one thing that we do is every time we put something in place, a custom class that is going to be used by somebody else, something that we have an opinion on, we always play with conditional on missing being. What I'm going to do is if I'm creating a custom class, doesn't really matter what this class is doing. I just create an interface and a default implementation. And I create a being of the interface annotated with conditional on missing being. If the application has a good reason to override that, it can always implement the interface in a different way and just provide the being. And I will just respect that. On other scenarios where it's not just an interface, but actually we talked before about the filters, for example. Filters are things that are just going to be there intercepting some creations, some calls, and we are going to do custom things. For example, we are customizing the buckets for the histogram on the latencies. Here we cannot just replace the bean. It would not be practical. I would need to know the name of the bean and a lot of things. Instead, what we can do is just play with the orders. What am I doing? In this case, I'm just configuring the metric when it's created to add a specific set of values on a histogram. OK, I'm going to do it first in the chain. If the application has another opinion, just go after me. Don't take the highest precedence. Take any other precedence. You will be asked after me, and you can simply undo what I did, or just do something completely custom. So again, we just have to play with orders. We have to play with what we provide should be just opinions, not things mandatory. There might be some things that are mandatory because otherwise things would not work, but in general, we try to stick to this principle here. Okay, and now just the final touch. So we already seen almost everything. Mainly, there's the same by just long. Every good project starts as initializer, right? Also the second best place in the world, in the internet, because the first one is this. So at Travix, we have this saying, just a joke. What I mean is that we have our own implementation, or actually a fork, a very, very light fork of an initializer that I can show you very quickly, where mainly what we have is, let me try to zoom in a bit. So what we have is the same thing as before. We haven't customized the UI because we don't care. All we do is we come to just the project metadata and then on the dependencies. And when we click here, we just have our own options here. So mainly, we're going to create a web application or a reactive web application, and potentially we can add masking or VI logging. So let's say I want to create a reactive application, and I want to add masking. That could be it. We just do this. It will add the starters. It will add the entire structure. And yeah, so when we come here now, let's just do a very quick summary. And then I will do a live demo very, very quickly because I'm just running out of time. So as a summary, Spring Boot provides everything we need, right? Almost everything we need. So Spring just provides a lot of things. All we do is not actually reinventing the wheel. We just bundle all those things because we need them in production. So I know all applications are going to need, for example, Actuator. I will just add it as part of my starter. And like this, many other stuff. What we do is, on top of that, we provide company-specific opinionated defaults. What this means is, Spring Boot is great because it's opinionated, but it's opinionated in a business-agnostic way. Each company will have its own requirements, and things that are just OK for Spring Boot in a general way are not going to be OK for our applications. So what we do there is we just have a different opinion, and we make it take precedence over Spring Boot ones. And then there might be scenarios where things are just too difficult to customize, or directly there's nothing available for us that works, and in those specific cases, we just extend it with custom behavior. But this is like the last resort. Usually, we try to just customize things that are there. OK, very quick demo. As I don't trust the internet at the moment, and I need to be connected to the VPN to set up the project, I brought it already from home. Hopefully, it works. So mainly, I hope you can see it right. I will be zooming in on important things. The application is already started up. So when I generate the project from the UI I showed you, it will just create this structure where we are going to add one thing already, our CI/CD file that is going to be needed. So we already know how it is with some comments on things you have to add. Then it will just add the application properties with the name of the application. And then it will just create the normal application class. And the POM. The POM is the important thing. I said I'm going to create a web application, a reactive web application, and I want masking. So you see the structure is different. Our parent, I'm going to try to zoom in a bit more. The parent is going to be the framework parent. The reason for that is I don't want Spring Boot directly. I want to control the Spring Boot version from the parent. It's one of the dependencies I want to be always fully patched. And then also I need plugins to be configured. So for example, we're doing compiling with zip. We're not using Docker files. We use zip. It needs a plugin. I'm just making it come through the framework, so all applications don't have to add it, even though otherwise it could be scaffolded. But if tomorrow we move from zip to something else, 150 repositories we have to touch. Then it's just the starter for web flags, the starter for masking, and then this is actually added manually. New M1, I have been with it for a week, and there are some issues, so I have to add this for the DNS to don't have some errors on the logs. It would still work, but it's not the best experience. So we have the application started up, and when we come to the application, pim pam pum, we can see that, for example, the application is already exposing the health endpoint. Sorry for the zooming. So we have a health endpoint for Kubernetes. It's already configured for us out of the box. We also have something like Actuator Prometheus. So we have the metrics, which means that we can have customized dashboards for all our applications. So a general dashboard, sorry, for all our applications would look something like this. So we have all these metrics on our applications where we know what exceptions are being thrown. We can see the latencies. We can see how many, well, pods, of course. We can see the latencies on each of the calls we do. We can have a look at if we have circuit breakers, which state they are. So all of this just comes from standardizing. If all applications produce exactly the same metrics in the exact same way, we can just create a dashboard and then just say, OK, where are all my applications? Here, I can choose any of the applications. I will have this metric available. So when I'm troubleshooting, it's just one thing I need to understand. We have others for just understanding the specific pods with micrometer and whatnot. And then when it comes to the logs, to application, what I did was just creating a hello world application. So what I have is a service class here. So a controller is actually, sorry, let me show the controller very quickly. Yeah. So I'm getting a get on hello. It will just call the service. And the service is simply creating a call to JSON placeholder. I don't want to create any API, and return it as a string directly. So when I come to hello, I can see that automatically, bim bam, I got it, right? Now what happened? One of the things I said happening apart from all the actuator stuff is I'm logging. So I can see here, for example, I'm logging let's go directly to the request. And I can see that when I'm logging here, let me zoom in. So I just have information of what's going on, client request response, the interaction with the web client, and I can see the headers. I can see that, for example, the bodies are just not logged, and it's saying they are not being logged. If I want to log them, I can just come to the code and say here, he said, I can do attributes, and in the attributes, I will know web client attributes, dot log request body, log response body, bypass, all the things I can do. Again, just self-documented. I know. Let's say, for example, I want to log the response body, because it's a get, a request body will not be logged anyway. And then from the properties file, we have exactly the same concept. We know our framework is called supply hub in this case, so I have supply hub, and just because I type SUP, automatically I have all the things that I can configure. And there's documentation for each and one of them saying me, okay, what am I doing? So for example, again, log response body. I just want to log the response body. Oh, come on. Okay, so log response body. True, and that's it. So now when I come back to the application, if I just restart it, yeah, and this will be it. I can just come to the application. Is it over, or meaning should I just wrap up immediately? Yeah, okay. So yeah, okay. So let's just see the last thing, and that's it. So JSON viewer, bim bam boom. Okay. And now when I come here, you see body log not log for this interaction, and response body is here. So now I just managed to log the response body, and then yeah, that will be it. Okay, so I believe that's it. Has been tight on time, but I think we made it. Okay, so if you want to scan there, it's just link to the slides and my contact details. And yeah, maybe anyone has any question very quickly. Oh, a lot of pictures. Okay, maybe some questions, yeah? I think here, for example, first.
Hi, we are following the same approach in our company. And how do you solve the problem when you expose configuration on some beans from the auto-configuration? How do you avoid them to make them primary to the whole context for the built-in configuration of Spring Boot? For instance, if you customize with a auto-configure object mapper or REST template customizer, this might affect the communication of your app through, I don't know, Spring Cloud Flow clients or whatever, because you are, there's no way to qualifying it, so it's getting a primary bean in the context, and it's affecting all the components, not only your domain ones. How do you solve this approach?
Usually, we don't have that issue because we just do normal calls, so or will be the same by a REST template or web client with no other stuff, and we want global configuration. There are ways I can show you later, probably. I mean, after the talk, because it will need some checking from me. But I know there were some scenarios where we were doing some calls to XML services. No, not XML servers. Actually, some yeah. I have to check. But no, I'm not sure. I'm not sure exactly how to do it, honestly.
Yeah, maybe you didn't.
Let's have a look. Let's have a look later. But I remember doing it, but I don't really.
Maybe you didn't get in the scenario of having a conflict.
We did, but a long time ago. So as I said, if you want to come to me after this, okay, and we can have a look. Any other question? Maybe we have time for one more. I think. Yeah. Can you shout?
Basically, when you auto-configuration classes, they are being evaluated after the current components come. So in beans, etc. Is that right?
Yeah, so it's evaluated after the scanning is done, in the sense that the definitions are already registered, but before the beans are created. So auto-configurations will kick in just understanding what's defined as, I want to create this, and then they will take precedence there, and after that, yeah. So they will be created afterwards.
Okay, thank you.
But yeah, you can just know what the application is providing always. I think